Today's lesson is about inverse functions. Now this is different from reciprocals. Reciprocals were secant, cosecant, and cotangent, and that's where you just flip it. But inverse is not that. So first thing I want you to do is just graph the parent sine function. So everybody right now, graph the parent sine function. Are you doing it? That's good. Whoa. Okay, so there's sister sine. Now we need to ask ourselves some of these questions. So first, is sine 1-to-1? We did this last semester by doing the horizontal line test. So we need to check, does sine pass the horizontal line test? No, because it hits the horizontal line more than once. So because it does not pass the horizontal line test, that means the inverse is not a function. However, when we graph the inverse, we need it to be a function. So we're going to restrict the domain. So we're going to cut off part of this graph to make it a function. So I'm going to look closest to the y-axis and figure out what do I need to cut off so that it passes the horizontal line test. So right here is where it'll hit it more than once. So I'm going to cut it here and the same thing over here. So I am only going to look at this section. So I restricted the domain from negative pi over 2 to pi over 2. So that's the part that I'm going to graph as the inverse. Now to be the inverse, you just flip x and y. So I'm going to write the table for this sine function. Here's x, here's y. The x value is negative pi over 2, 0, and pi over 2. The y values there are negative 1, 0, and 1. To put them on this graph, though, I'm going to flip them. Notice the x and y axis are also flipped. So I'm going to plot negative 1, negative pi over 2. Negative 1, negative pi over 2. 0, 0 flipped is 0, 0. And then 1 pi over 2. And now I'm going to connect the dots. This is still a sinusoidal, so still squiggle squaggle it. Don't draw a straight line. So this is inverse sine. The way inverse sine is written is either with a sine to the negative 1, or you can say arc sine. Weird, right? But they mean the same thing. So let's answer some questions about inverse sine. First, what's the domain? Well, let's look. Negative 1 to 1. Now, what is the range? Remember, bottom to top, so negative pi over 2 to pi over 2. We're using hard brackets because it actually touches those points. Okay, what angles are allowed in this function? Now this is where it gets kind of funny because you have to remember your unit circle. So I'm going to break my graph up into these 4 sections that represent the 4 quadrants. So if you think about your unit circle, to go from 0 to pi over 2, that's quadrant 1. Pi over 2 to pi, that's quadrant 2. But now if I'm going down the unit circle from 0 down pi over 2, that's quadrant 4. So this has to be quadrant 3. So where is sine inverse allowed? Right here is where it's drawn. So quadrant 1 and quadrant 4. Okay, even, odd, or neither. This is reflected across the origin. So what is it, everybody? Odd, good job. Okay, so let's look at some transformations. We're not going to do even, odd, or neither. We're just going to do domain and range. So, first thing I'm going to do here is write down the parent domain and ranges. So it's always going to be negative 1 to 1 for domain and negative pi over 2 to pi over 2 for range. Okay, so in this equation, all it's doing is it's shifting to the left, or no, right one, because you always do the opposite inside the parentheses. So this is adding 1 to the x values. Well, which one is x values, domain or range? You guessed it, domain. So I'm adding 1 to both of these values. So my answer, -1 plus 1 is 0. 1 plus 1 is 2. So here is one of my answers. There's my domain. Now nothing happened to the y values, so this stayed my range. Let's try another one. So domain, range, I'm gonna write the parents. And now I'm gonna look at what's happening. So this 2 is only affecting x again because it's in the parentheses. And remember, whatever's in the parentheses, you do the opposite. So instead of multiplying by 2, I'm gonna divide by 2. Again, this is the x values, so I'm only gonna do it to domain. Okay, so -1 divided by 2 is -1/2. 1 divided by 2 is 1/2. And there's my domain. Nothing happened to y, so this is still my range. Again, everybody, number 3. Domain, range, this is so much fun. If I'm going too fast for you, just pause the video. Okay, now sister pi over 4 over here is not in the parentheses. That means it's affecting the y values. Well, the y values is the range. Now you do what it says. I'm gonna subtract pi over 4. So since that's all I'm doing, that means this domain is still the domain. All right, we're adding and subtracting fractions, but it's okay. We're really smart. So -1/2 minus 1/4. What is it, Kyla? You said -3 pi over 4? Good job. I knew you would know it. Pi over 2 minus pi over 4? Pi over 4. If you don't know your fractions, you better sister study. There's the range. Y'all can do that one for homework. Let's do cosine. Okay, so for cosine, we're doing the same thing. First, let's graph the parent function. Doot, 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 doot. I know Grace liked that. Okay. There is cosine. Ooh, this says sine. It should say cosine. Is cosine 1 to 1? Does it pass the horizontal line test? No, sis. Which means it's not a function. So let's restrict the domain. So again, I can't do anything over here because it's gonna hit more than once. So let's chop it off here. And then I could go left or right. I'm gonna go right to stick with the positives. Excuse me. So think about where it's gonna pass the horizontal line test. I need to cut it off right here. So this is the section that I'm gonna make the table and graph. So the place that we restricted the domain was 0 to pi. Oh no, hard bracket. Phew. Okay, let's make our table. X, Y. So 0, 1, pi over 2, 0, pi, -1. But to get to this graph, we're doing the inverse, so I'm flipping them. So 1, 0, 0 pi over 2, -1 pi over 2. So here is the inverse graph of cosine. So we either write it as cosine to the -1 or arc cosine. Let's answer some questions. What's the domain? -1 to 1. Now the range is different here, 0 to pi. What angles are allowed? Let's look back at what we did for sine. Cosine's up here, so quadrants 1 and 2. Even, odd, or neither. So it's not reflected across the origin. It looks like it's reflected across the y-axis, but if I fold it, will they kiss? Nope. So it's neither. So here's the domain, here's the range. I want you to do the same concept here with these parent functions. Cool. We have one more graph, sister tangent. So we just did this one recently where we graphed tangent. Remember, tangent starts on 0, and then every pi away is another 0. And then between the zeros are the asymptotes. Do, 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 do. Do, 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 do. Do, 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 do. Sister messed up right here. We get it. Okay, and then up, down. Remember, tangent's increasing. That's part of your Schoology quiz. Make sure you know that. Pew. 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 Okay, is tangent 1 to 1? Near. It doesn't pass the horizontal line test. So it's not a function. How are we going to restrict this domain? Well, if I want to pass the horizontal line test, I only need one of these sections here. So I'm just going to pick one of these sections. Now this domain is going to look different. It's going to have parentheses. Why is it going to have parentheses instead of brackets? Well, let me tell you. There's asymptotes there. Huh, crazy. Okay. For our table, we have x, we have y. I'm going to start with the asymptote, negative pi over 2. There's not really a y value. It's undefined because it's an asymptote. This little guy is pi over 4, and that's at negative what should be 1. Ugh, who did this? Because the amplitude is 1, remember? Negative 1, 0, 0, pi over 4, 1, pi over 2, undefined. Pewee! Okay, let's flip them. So at both of these pi over 2's is where our asymptotes are. Cool, 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 cool. At negative 1, I'm going to negative pi over 4. At 0, 0. At pi over 4, 1. And the other pi over 2 is negative. Oh, that was at 1. This isn't. It's 1. 1 pi over 4. We did it. We did it, everybody. Cute. Now, tangent's a little bit different because she has arrows. So we need arrows right here. Yippee. So there is our inverse tangent. That could be tangent negative 1 or arctangent. It means the exact same thing. Quickly, let's finish up by going over all of these guys. So domain, it goes left and right forever. So what is that? Wow, you guessed it, negative infinity to infinity. The range, bottom to top, is going to have soft brackets because of our asymptotes. So negative pi over 2 to pi over 2. What angles are allowed? So let's look at what quadrants that is. It looks like it's the same as sine where it's in the middle here. So that's 1 and 4. Even, odd, or neither. Even's reflected across the y-axis. That's not her, but she is reflected across the origin. So that's odd. And that is inverse graphing. So all you have to do now is finish up page 22 and finish that last one on page 21. Don't forget to reference your domain and range for the parent functions. Bye!